Good evening. Today concept is how to find electric field intensity at a point due to a given point charge. So how to find electric field intensity at a point due to a given point charge. For example, so here Q is the given point charge. Q is the given point charge. So we have to find electric field intensity at point P. We have to find electric field intensity at point P. Now this point P is at a distance R. Okay. So here Q is the given point charge. So we have to find electric field intensity at point P. This point P is at a distance R from the given point charge. So what is the formula we have? Finding electric field intensity due to a point charge, E equal to KQ upon R square. Now this is the equation to find electric field intensity due to a given point charge. So in this equation, we have electric field intensity proportional to Q and electric field intensity proportional to 1 upon R square. So from this equation, so electric field intensity directly proportional to magnitude of the charge. Q means magnitude of the charge, and electric field intensity is inversely proportional to square of the distance. Electric field intensity is inversely proportional to square of the distance. So here important points. So E proportional to Q. E proportional to Q, that means greater. So I told you already, Q means magnitude of the charge. Q means magnitude of the charge. Okay. So greater the magnitude of the charge, greater the magnitude of the charge, stronger the electric field. Stronger the electric field. So here electric field and the charge both are directly proportional to each other. So greater the magnitude of the charge, stronger the electric field. In the same way, smaller the magnitude of the charge, smaller the magnitude of the charge, weaker the electric field. Weaker the electric field. So this is the first point. So in this equation, we have electric field, magnitude of the charge, both are directly proportional to each other. So greater the magnitude of the charge, stronger the electric field. In the same way, so smaller the magnitude of the charge, weaker the electric field. So the next one is we have E proportional to 1 upon R square. So next important point, E proportional to 1 upon R square. So here that means this electric field intensity is inversely proportional to square of the distance. So we have inversely proportional. Okay. So as a distance R increases, electric field decreases. So the first point is as distance R increases, electric field intensity gradually decreases. So that is the first point. Now second point is as R tends to infinity. Okay, that means at greater distances. Okay, as R tends to infinity means at greater distances. As R tends to infinity, so electric field tends to 0. Okay, so here as R tends to infinity, the electric field tends to 0. So these are the 2 points we have. So the first one is E proportional to Q, the important points. Next one is E proportional to 1 upon R square, the important points. Okay, next. So next point, in the case of positive charge plus Q, direction of electric field is away from positive charge. So for example, here we have a positively charged particle. This positively charged particle produces electric field. If it produces electric field, what is the direction of electric field? So in the case of positive charge, the direction of electric field is away from positive charge. So away from positive charge. Same thing, away from positive charge. Same direction, away from positive charge. So like this. So in the case of positive charge, what is the direction of electric field? That is away from positive charge. For example, so here we have plus 4q, a positive charge. So it is an isolated positive charged particle. Okay, it is isolated positive charged particle. In the same way, we have one more positive charged particle. Okay, so one charged particle having charge plus 4q and one charged particle having charge plus q. I told you already in the previous point. So greater the magnitude of the charge, stronger the electric field. Stronger the electric field means we have more number of electric lines of force are present. Okay, greater the magnitude of the charge, stronger the electric field. Stronger the electric field means we have greater number of electric lines of force are present. And in this figure, so here it is plus 4q, so greater the magnitude, of the charge, stronger the electric field, so more number of electric lines of force are present. So in this figure, comparatively smaller magnitude of the charge, so smaller magnitude of the charge, weaker the electric field. Weaker the electric field means less number of electric lines of force are present. Okay, so stronger the charge, stronger the magnitude of the charge, so stronger the electric field. So here smaller the magnitude of the charge, weaker the electric field. So in the case of positive charge, what is the direction of electric field? So the electric field is away from positive charge. Okay, so in the case of positive charge, electric field is away from positive charge. Same thing, we have positively charged particle, electric field is away from positive charge. Same, we have positively charged particle, electric field is away from positive charge. So in the case of negative charge, electric field direction is towards the negative charge. So for example, we have a negatively charged particle. In the case of negatively charged particle, so what is the direction of electric field? Towards the negative charge. So it is the direction of electric field in the case of a negatively charged particle. So in the case of negatively charged particle, What is the direction of electric field? Electric field is towards the negative charge. So in the case of positive charge, the direction of electric field away from positive charge. Okay. In the case of positive charge, electric field is away from positive charge. In the case of negative charge, direction of electric field is towards the negative charge. Okay. So next. So E versus distance graph. E versus distance graph. So before starting the graph, some important points. So if direction of electric field is along positive direction, we draw the graph on positive side. We draw the graph on positive side. In the same way, if direction of electric field is along negative direction, we draw the intensity graph. We draw the intensity graph on negative side. Okay, so see the point once again. If direction of electric field is along positive direction, then we draw the intensity graph. So we draw the intensity graph on positive side. We draw the intensity graph on positive side. In the same way, if electric field direction is along the negative side, so we draw the intensity graph on the negative side. For example, here we have a positive charge. So for example, we have a positive charge. So we have to draw the graph between intensity and distance. We have to draw the graph between intensity and distance. So it is the intensity, then after it is a distance. So it is the intensity axis and it is the distance axis. Okay, so what are the points we have? So first one is E proportional to 1 upon r square. That means as a distance increases, intensity decreases. Okay, as a distance increases, intensity decreases. That is one point. So second point is, in the case of positive charge, what is the direction of electric field away from positive charge? Okay, in the case of positive charge, electric field is away from positive charge. Okay, so it is the direction of electric field away from positive charge, like this. So here, as a distance increases, so intensity gradually decreasing in that way. So as a distance increases, intensity decreases. Okay, so the graph is like this. Okay, one more thing here. The intensity direction is along positive direction. Okay, intensity along positive direction. So we draw the graph on the positive side. So the graph will be like this. So in the same way, in the case of positive charge, what is the direction of electric field? Away from positive charge. Okay, so direction of electric field is away from positive charge, like this. So as a distance increases, intensity gradually decreases. But here the intensity is along the negative direction. intensity along the negative direction. So we draw the graph on the negative side. So we draw the graph on the negative side. So as the distance increases, intensity gradually decreases. Okay. So the graph will be like this. As the distance increases, intensity gradually decreases. Okay. So in the case of positive charge, electric field away from positive charge, away from positive charge. If electric field in positive direction, we draw the intensity graph on the positive side. Okay. If electric field is on the negative direction, we draw the electric field graph on the negative side. So it is in the case of a positive charge, the intensity distance graph. So for example, if we have a negative charge, we have a negative charge. So we have to draw a graph between intensity and distance. We have to draw a graph between intensity and distance. Okay, so listen. So in the case of negative charge, I told you already, in the case of negative charge, electric field is towards the negative charge. So it is the direction of electric field towards the negative charge, okay, like this. Same thing in the case of negative charge, what is the direction of electric field? So towards the negative charge, like this. Okay, so here see one thing. So in this case, electric field is in the negative direction. Electric field in the negative direction. So we draw the graph on the negative side. So we draw the graph on the negative side. So as the distance increases, intensity gradually decreases. Then after, so here, so intensity is in the positive direction. So here intensity in the positive direction. So we draw the graph on the positive side. Okay, we draw the graph on the positive side. So this is the graph. As the distance increases, intensity gradually decreases. So this is the intensity distance graph in the case of a positive charge and in the case of a negative charge. If intensity in the negative direction, we draw the graph on the negative side. If intensity in the positive direction, we draw the graph on the positive side. Okay, so thank you.